Hello, dear students. Wish all of you are fine. Today we are going to discuss about the manufacturing process of bread. In our last class, we already know about what is bread, what is the ingredients and their functions. With that, we also read about different kinds of dough that is used actually in preparing a bread. In our today's class, we mainly emphasize on manufacturing process of bread, that how bread is prepared and two, how it's packed and go to the market. So let's get started. First of all, there are some machineries that is mainly used in our different kinds of bread making industries. What's they? Like it's called flour shifter, mixer, dough elevator, dough divider, rounder, interprovers, molder, some kinds of boards, then another kinds of provers that is called final provers, then oven, different kinds of depanner that is from where the breads actually removed from the pans. Then there is some cooling tunnel, with that some slicer or baking machines and wrapping and packaging machines. And in this, most of the machines you already know in with your previous classes, how it's look like and what's its function, and another things you will know in our classes. First of all, that is a flowchart how the bread can be made. And first of all, that is flour and other ingredients you have to prepare first, then you have to bring it in your according to your recipe. After that, you have to mix that. After mixing, there will be some resting time and then kneading. Then you will divide it. Then it will go for proofing. After that, it will go for baking, cooling, slicing, and last of all, it will go for packaging. And actually, there is just a phase, or you can also say how machines are situated in the production area. From flour shifted to packaging section, all of the things are mentioned there. For example, here, first of all, it mixes there. Okay, then after mixing, there is some rolling of the doughs, then forming. After forming, it's go for fermentation. After fermentation, it's again for forming. That means forming will be two types. First of all, you have to cut down the dough in small pieces. Then it will be go for your desired shape that if you want to make. Then it will go for proofing chamber for fermentation process. After proofing, it go for freezing sometimes, and sometimes it is not freeze. Actually, it go directly to the baking section. It depends or vary this section from industry to industry. After baking, it go for cooling tunnel. Then after cooling, it go for packaging section, then storage. That is the whole process that we are going to discuss in our today's class. And it is the formation in a production area of any kinds of baking industry. So there are some stages that we are going to read. First of all, weighing, mixing, optimum to development, then fermentation. With that, gas production and retention, fermentation losses, knockback, stage of deviation, then baking. After that, depaning, cooling, wrapping. And last of all, the slicing and packaging. If you're going for packing, first of all, that is the steps in bread making operation, that is we are going to discuss. In case of weighing, it's the very simple step that the according to ingredient, all of your baking materials or ingredients you have to weigh first, and you have to prepare the process. Okay, and after that, the second will be the mixing stage. The mixing stage can be two types. One is manual with hand, and another is machines or with the mixture. Okay, so in case of that is a mixer of different types, or that we say that manual and machines. Manually you can mix with hands, and in case of machines, that can be two types of mixture. One is non-spiral, another is two-speed spiral mixture. Okay, but best one is the two-speed spiral mixer. And in case of, actually we see the normal spiral mixer functions, that it can, how it's work. It works actually in two types. So one is slow stage mixing, another is fast stage. Okay, so these two stages we can check between the machines. In slow stage mixing, what happened first? Actually, the ingredient is mixes or blend together within 2 minutes. It's called the slow stage. That the speed is less at that time. And then it is called the fastest mixing. Actually, that is the step when you dough develop very quickly. Okay, or we can also say the optimum dough development in that stage. And in our last class, I also already mentioned it, that what happened in fastest mixing. Okay, that in case of fastest, actually what happened, that optimum dough development, that whenever we taking a, I just mentioned like that, it will be a dough, and from there we will take a small pieces of dough, and that these small pieces of dough actually will stretch in all around in all portion. Okay, if it's not tear up, okay, so it is now developed properly, and then you can remove the dough from the machines. It's called the optimum dough development. Okay, so that was the 2 stages mixing that happen in machines actually, and there is some mixture there what is mainly used in case of bread production. Then our third stage is optimum dough development, that I already mentioned, that you can understand when the dough is developed, then you will remove it from the mixture. And another important thing that is actually keep in mind, that is the temperature of the dough. Okay, that we mentioned in our last class, the dough temperature or ideal growth of the yeast will be 25 to 28. Okay, and in case of machines, as machines is very vigorously rounding, so temperature is automatically increase in the dough. Okay, and with the thermometer it must be checked. If the temperature is higher, then you have to keep the dough for some time freezer for cooling down, or for reducing the temperature to 25 to 28. Okay, then our fourth stage is fermentation. As you already know, in fermentation process, what happened is cell actually converted sugar into carbon dioxide and alcohol. Okay, and in that stage, or you can also say with the process, some changes actually happen. Okay, what is that? That is some physical changes and some chemical changes. In case of physical changes, as we can check with that, the volume of the dough actually it increases almost 5 times from its original volume. And another important thing, the temperature that is visible, that is 5 to 6 degrees centigrade, almost the temperature is increased during fermentation. And the number of the yeast cell is also active mode, and it also increases about 26 to 56 degrees centigrade. And the moisture is lost at that time, and with that the dough's consistency actually very much changed. First of all, though the dough was somehow hard, but after the fermentation it will be very much soft, elastic and extensible. And second is our chemical changes. What happened there, the pH of the dough actually reduces almost 5 to 5.5 to 4.7. That means your pH will be acidic due to production of different kinds of acids like acetic, lactic, sulfuric, hydrochloric, different kinds of acids. Actually, different kinds of chemical reaction happen in your dough, and during that process, different kinds of acids actually produced in different kinds of dough. And maltose is formed there due to diastatic enzymes by acting on a starch. With that, we already know the carbon dioxide production, and gluten is also formed there, and proteolytic enzyme help in that process. That is actually the changes that happen in physical and chemical in during fermentation. And the fermentation actually depends on some factors like types of flour, quantity of the yeast, temperature of the dough, or presence of the sugar. It actually depends on the fermentation rate or that kinds of changes. Okay, that is some factors. Then actually fermentation control. It is a very important point during fermentation, because in case of fermentation, it's very important to control that fermentation. Why? Due to two things actually. That one of that, if your gas is produced Okay, if your gas is produced more, if your gas is produced in the peak point, okay, but the gas before the gas retention capacity, then what happened? Gas will be dissipated, or it will be actually lost. We can also say how it is. For example, if you think that gluten network is not properly formed, okay, your gluten network is not properly formed, okay, but your gas is produced in high strength. So what happened then? Your gas cannot carry by the gluten, so it will be lost, and your dough will be not raised at that time. On the other hand, okay, if the dough reaches its optimum gas retention capacity, that means if your gluten form properly but your gas is not produced, then what happens? Again, gas will be lost. So it's very much important to control the process, as it will happen at the same time. Gluten will be formed at the same time. With that, your gas also be produced, and gas can be retained within the gluten network. So we have to control the fermentation process. Okay. Then our gas production and retention, actually it is some factors that how it increase or decrease, like if uh, addition of malted sugar, increase with yeast concentration, presence of yeast food, and the temperature, highest temperature, you can also say if it's like that, that your gas will production will be increased. But if the opposite thing happen, that can decrease your gas production, like instead of sugar, addition of salt, okay, and additional amount of is food, like it's your sugar production, your sugar given is not as the appropriate amount. During the yeast, it's excess. For example, for 5 gram of yeast, you have given almost 500 gram of sugar. So what happened? Yeast will be tired to produce carbon dioxide, okay, and then gas production will be decreased. And another is the temperature, that if it will be above 35 degrees centigrade, then your gas production can be decreased also. With that, gas retention, that is, you already know gas is retained actually in the gluten network, and it's governed, or it's the process happened by chemical and physical factors such as minerals, moisture, pH, different kinds of enzymes, do expansion or knocking back, that all of the things that actually act on gas retention process, that is how much amount of the gas will be retained within the gluten network or within your dough. Then our next one is fermentation losses. In case of fermentation, there is also some losses. What is that? It's actually 0.5 to 4%. Average, it's 1%. Okay, and the loss actually nothing else. It's loss in moisture. Okay, many of the moisture or most of the moisture actually losses during fermentation, and its rate almost 1%. Then knockback, this process I already discussed in your last class. I again mention it. Knockback is very much important. Why? Because if you don't knock back within your dough, that process is called the knockback process. So what happened? Your dough will be very much porous, or it will not appropriately aerated. Why? Because excess carbon dioxide gas will give pressure in the cell walls of the dough. So your cell wall will be dispersed, okay, or it will be spoiled, or it will be ruptured. So your dough cannot be raised, or can during the baking time it cannot be aerated properly, okay. So it's very much important, the knockback process. And the punch is actually normally given at the time of 60% of the fermentation is complete, and second punch actually given normally half time required for the first time punch. That means after first punch, almost you can also say after finishing the fermentation process, second punching actually given. And then our stages of deviation. In case of stages of deviation, actually these stages of deviation vary, okay. I have mentioned here 3 shape, but in different kinds of industry actually vary within pre-shape and final shape. For example, In case of pre-shape process, what happened? It is an intermediate shape. In that process, it is given in all of the industries, okay, or all of the process. That is, you manually bake or you industrially bake. That is, a dough is divided in according to your requirement. Okay, for example, if you are preparing 500 gram of bread, or you are preparing 250 gram of bread, if within that variation your dough actually is divided in different portion by the measurement, that every dough will be same size. Okay, after that it's called the bench rest. So, and third one is called the final shaping. The difference actually happen within bench rest and the final shaping. Sometimes after the pre-shape process, finally it's go for baking. Okay, it's go after pre-shape, it's go for final shaping or molding. But in some cases it's given the bench rest. What is that? That means after final shaping, it's given another resting time for 15 to 20 minutes before final molding. But in some industries, after the pre-shape, it's directly go for the molding process. They just skip that process of bench rest. Okay, so actually the main thing is after pre-shaping, you given the dough different shape or different grams according to your requirements. You will divide the dough. After that, if you want, you will give 15 to 20 minutes long rest that, and after that, just different kinds of folding is given to the dough, and it's given some types of rest again, and after that going to final fermentation or final proofing. That is, if you're preparing any bun, or if you're preparing any loaf bread, what is your shape you will give there in your final shaping process. Okay, and after that it's again given 20 to 15 to 20 minutes or more. Sometimes it is half an hour time to again relaxing the dough or further fermentation. Like that, you are giving that shape. This shape is small, but that is bigger than that. That during fermentation process it will again increase in that shape. It gives the softness of the dough. Okay, and this shape is given in every kinds of doughs or in every kinds of machines. If it is a automatic machine industry or manual, it's this process is mandatory, because after final shaping you have to give them rest. So again carbon dioxide will be produced there, and then it will give the softness and sponginess of your dough. Okay, then our final is after final shaping you will go for baking, and the ideal temperature actually depends on baking type of bread. It's not for equal for all types of bread, but usually it is 180 to 220 degrees centigrade, and it's 20 to 30 minutes time. Within that, normally all kinds of bread actually baked. And in that process, there are also two types of change we can check. One is physical, another is chemical changes. Okay, in case of physical changes, there is actually two kinds of changes happen. One is film formation, another is oven spring. What is film formation? Actually, film formation like that, when the dough is placed in the oven, it is the instantaneous formation of a thin expandable surface film. Okay, whenever you are baked a bread, you can check that whenever it come out from the oven, there is a thin film is actually prepared on the upper portion of the dough. Okay, whenever you will pull it, it will be just come out from the bread. Okay, that is actually prepared in film formation process. And second one is oven spring. What is that? In case of oven spring process, actually it's expansion, nothing else. It's expansion of the dough volume about 1/3 of the original size. Okay, and what happened here? It's actually happened due to some things. That is, there are lots of airs, there are lots of gases in your dough. With that, there are moisture in your dough. Whenever this all of the things actually come out from your dough and get pressurized in your cells of the dough, or then your dough is automatically actually increase the volume from the original. It's called the oven spring process. Okay, then our second one, that is chemical changes. In chemical changes process, we can check three kinds of changes. First of all, we know its activity, that is almost died in case of 60°C. Then we also know that is starch is gelatinized and it begin about 54°C, and its transfer from polysaccharide to a normal one, or you can also say the monosaccharides, and the gelatinized happen in starch. And then is gluten coagulation. Okay, that is gluten is coagulated almost at 74°C. It is associated with or related with the starch gelatinization. How it is? The starch gelatinization is associated with the water absorption, and it is resulting when the water is removed from the gluten, and the gluten is denatured then and it coagulates, and for that reason your bread is so much spongy and soft, because we know if gluten network is present there, then it will be not so much soft, it will be harder one. That means gluten is broken down in case of baking of oven. Okay, so that is our changes that happen, our physical and chemical changes in baking process. Then our another option, that is, or another process we can also say, after the baking it will be depanning, cooling, or wrapping. Okay, your baked bread depending from the your mold, then it will be cooled down, then it will be wrapping, and our last one, that is, it will be slicing, and then it go for packaging, and now it's ready to eat. So that is actually our bread manufacturing process from our boiling to slicing and packaging. Hope you understand. With your help or for your help, I have given there some links of YouTubes. Please go through that for your better understanding. And thank you for today. It was for our today's class, and we will discuss it more in our regular class.